So the first characteristic is domain. That's all your X values. So you want to think about your X axis and you want to read left to right. So left to right. Range is all your Y values. So you want to think about your Y axis. And just like we read left to right, it's like smaller to bigger. You want to read your graph like down to up, for lack of a better way of putting it. Do you remember last year your notation for this? It's called set notation, and you had like a swirly bracket and like X and then a bar that was such that, and you had the little alligator mouths. We don't use that in pre-calc at all. Don't put that on your paper, I will have to mark it wrong. We do what's called interval notation. It involves parentheses and brackets. So for both of these, you're going to put parentheses if your number is not included. And you're going to put a bracket if it is included. And what I mean by included is it exists on the graph. It is there. Like the graph goes through that value. We're going to do examples and you're going to see it. So you'll see what I mean. But for domain, you go all the way from the left to all the way on the right. For range, you go down to up. It's smaller to bigger. What also helps people is to just imagine a number line. Like, you don't have to write this, but if it helps you, just to imagine a number line with negative infinity on one side and positive infinity on the other. It's like you're going from everywhere with small numbers to everywhere with big numbers. You're sweeping, okay? So what I want us to do is number 4. We're going to do the characteristics and then go to the notes page, and then we'll come back until we get the whole thing filled in. I picked number 4 because it's going to have most of these characteristics. What is this one called? Number 4. Quadratic, good. And again, I put like one of each type of function on. So that one's quadratic. Oh, let's review the transformations because that's how you get a graph. There are 2 things that happened to this. What happened to the graph? Down 3 and horizontal shrink by half. So it like got compressed. You want to imagine it being narrower, like you took it and squished it this way. So you're going to start down 3. So go down 3 from the origin. We're going to put a point. And I would just like one more point on either side. So like just make a little table off to the side here. What do you want to try and plug in? And again, you can't be wrong. If it doesn't turn out nice, we'll pick something else. What number do you want to try and plug in? 2 is good. I'm wondering if that might go off the, you know what, 2 is going to go off the grid. That's not a bad choice. It's just, it's going to be like a larger number. Let's do 1. So let's plug in 1. Come with me on this. This is what you got to be able to do without a calculator. 2 times 1, 2 squared, 4, and then 4 minus 3 is 1. So we got the point 1, 1. And if you feel like you can do that in your head, you don't have to make a table. That's an optional thing. It's just a good thing to fall back on. Now we talked about symmetry and even and odd. Where else can I put a point without doing any more work? Negative 1, 1. Because it's going to be a U shape. And so I'm going to get that symmetric point. So something like that. So we're going to do domain and range. Maybe just watch me point to this first. Domain, you're going to sweep left to right. Now, it's a little tricky because it got squished a bit. I know it looks like both those arrows are pointing straight upwards. But do you get that the U shape is going to keep expanding? Like if it went off the paper and off the desk and down the hallway, like it's going to keep going left and right forever and ever and ever forever. Okay. So that means you get all reals. It means everything. So the way we write that is negative infinity to positive infinity. And those get parentheses. You can't ever bracket an infinity because infinity is not a value. It's not a thing. It's like an abstract concept that means you're going on forever. Don't think about it too hard. We as human beings can't really like conceptualize infinity. But everywhere on the left to everywhere on the right, you got everything. So range, watch me point to it. This one will be a little bit more interesting. You're going to go downwards to upwards, small numbers to big numbers. There's nothing down here. Where do we start? What Y value is the beginning? -3 to infinity. Okay, so let's write that. -3 to infinity. And then we have the bracket parenthesis conversation. Infinity has to have a parenthesis. You can't put a bracket on that. But is -3 actually on the graph? Like, does that point exist there? That exists there, so it gets a bracket. So one side's a bracket and one side's a parenthesis. And I will never forget, as long as I live, the one year I showed that to a class and this kid in the back goes, "That's stupid." And I was like, it's not stupid. One of them's included and one of them's not. So you can have a bracket and a parenthesis. They will not always match. Okay, but I just always bring that up because I thought it was hilarious. Stupid. I was like, you're entitled to your opinion, but that's still the answer. Okay, left to right, down to up. Go back to your little cheat sheet and we'll do the next characteristic. We'll do a characteristic and then go back to the example. So an x-intercept is going to be where the graph touches the x-axis. It's going to be something, comma, 0. So you'll have 2, 0 or -7, 0 or whatever it is. And the way you get that is you're going to set your equation equal to 0. Take the whole thing and just set it equal to 0, and then you have to solve it. So sometimes that involves work. Sometimes you have to actually like do work for that. And it's a major bummer. Y-intercept is always going to be 0 something. And for that one, it's a little easier. You just plug in 0. So you just plug in 0 and see what you get back up. I want to draw your attention to this. Do you see how x-intercept has like maybe an S on that, but y-intercept doesn't? You can have more than one x-intercept, but you can only ever have one y-intercept. How come? Like, imagine your y-axis. Can it hit the y-axis more than once? It won't be a function. It fails your vertical line test. Okay, so this one you can have multiple. This you can have only one. All right, so we'll go back to the example. X-intercepts. Well, you know what? Let me do the y-intercept first because it'll be easier. Where is this graph touching the y-axis? Yeah, now you have to write it as an ordered pair, though. So 0, -3, 0, comma, -3. The x ones are going to be a little bit of work. This graph does touch the x-axis, but it's not at nice perfect answers. Okay, I don't have nice exact perfect answers on the x-axis. Now we have a little bit of space here. So just take the equation, your 2x squared minus 3, set it equal to 0, and welcome back to algebra class. We're going to solve that. So first of all, the parentheses. If you square 2, what are you going to get? 4. And if you square x, good, okay. I was worried that was going to be a fight, but you guys got that. All right, so 4x squared minus 3 equals 0. So we took care of the parentheses. Then what? And I'm going out on a limb here, assuming you know how to solve an equation, but I want to see what you know. Yeah, add 3 to both sides. Divide by 4. I'm going to come over here. So that'll be x squared equals 3/4. Don't panic because it's a fraction. That's fine. You're going to get a lot of goofy answers in here. Welcome to advanced math. Ooh, to get rid of a squared, you're going to square root. I will be really impressed if anyone remembers this. When you do a square root, you have to put a symbol in front of it. Oh, very good. Plus and minus. Whenever you square root, you're going to get plus and minus. So we're going to get plus and minus square root of 3/4. Whatever that is, here's the good news. Because you're not allowed a calculator, you don't have to worry about that. That's the answer. Plus and minus square root of 3/4. Whatever that is. You get that it would be some crazy decimal, right? Irrational. Okay. So when you do your x-intercepts, you're going to get square root of 3/4, comma 0. And you're going to get negative square root of 3/4, comma 0. And when you look at the graph, does it make sense that there's a positive and a negative one? Like visually, does it make sense? Yeah, because there's one there and one there. Hey, you know what? I'll type it in for us and see what it is. Square root of 3/4, 0.866. So positive 0.866 and negative 0.866. So again, x-intercepts are sometimes a little bit of work. You'll be okay. All right, go back to your little cheat sheet. Increasing and decreasing, you need to read left to right. That's really the only thing I have to say about that. If you want to extra make sure you read it left to right, maybe write x values. The only time people mess this up is if they use the y values instead of the x values. Because guess what? You walked through that door knowing what the words increasing and decreasing meant. I'm not teaching you that. What does increasing mean? Going up, and decreasing, congratulations, you've been alive for 16 years, okay? Like, I'm not teaching you what those words mean. I'm teaching you the notation of how to write it. So read left to right. Also, always use parentheses for these. Just always parentheses. Don't ever put a bracket with it, just use parentheses. So let's go back to number 4 and we'll do our increasing, decreasing. So watch me point to it. We're going to start on the left and go to the right. So over here to over here. As I start on the graph and trace along, hey guys, what is it doing? Decreasing. This is the left side. This is the right side. If you want to label negative infinity and positive infinity, maybe that'll help you. All right. So we decrease from negative infinity until this center point, but good. The x value of that point is 0 because the common mistake is people put -3. And I get totally why that happens. But do you see how it's 0? And then, okay, negative infinity to 0 is our decreasing. The other thing is people will be like, but Miss Cole, that arrow is pointing upwards. It doesn't matter. You're going left to right. So negative infinity to 0. And then at 0, we turn around. Now what's the graph doing? So increasing is from 0 to infinity. You should always start with a negative infinity and end with a positive infinity, and they'll link together. So negative infinity to positive infinity. All right, cool. Go back to your little cheat sheet. This first one's taking us a long time because I'm having to go over all the things. It'll go faster after this. All right, relative maximum and minimum. Again, you know what those words mean. What's a maximum? The highest. And a minimum? The lowest. Okay, what I'm teaching you is the notation of how to write it. So the way it gets written is it's the y value at x equals whatever the x value is. Basically, you reverse it. Instead of x comma y, it's y at x equals whatever. Is that ringing any bells from last year? Like you did this stuff last year. The only thing different is the interval notation. Okay. So let's look at our picture. Do we have a relative maximum or a relative minimum? Minimum. Is there a maximum? No. So we're just going to say none. Or you could write NA, or you could put a frowny face. I don't care. You have to put something there to indicate that you read the question and you know that there's not a response. All right. So this minimum, it's the 0.0 comma -3, but you would write -3 at x equals 0. You just have to remember to reverse it. And it's like not hard. The notation is just hard. There won't be a relative maximum because these arrows are going to do what? Yeah, and infinity is not a number. You can't say the maximum is infinity. That's not a thing. Like, there's not a peak. There's not like a top of the mountain kind of point. Okay? All right, back to your little cheat sheet. I'm going to go over this. This graph obviously doesn't have any asymptotes, but a horizontal asymptote would be y equals whatever. A vertical asymptote would be x equals whatever. And that comes from your Hooy-Vux. Okay? I didn't draw a very straight line there, so I'm going to fix that. It's going to bother me. That's just Hooy-Vux. Horizontal is y equals, vertical is x equals. And the end behavior. Do you remember how you wrote it last year? As x arrow negative infinity, as x arrow positive infinity. I'm going to change that on you. It means the exact same thing, but we do the calculus notation in pre-calculus, which is what's called a limit. The problem's not any different. Just the way you write it is going to look a little different. You will get used to it, I promise. It's actually shorter to write. So you write LIM, that's limit, x arrow negative infinity of the function. It's shorter than writing as x arrow negative, like it's shorter. okay? And you would say that equals, you know, whatever the left side does. Negative infinity is the left side. And then you would have limit x arrow positive infinity of the function equals, and then that's where the right side goes. So it's just the left side and the right side. All right, so let's try that on number 4. And I don't care which one you write where. I usually do negative infinity first and then positive infinity. But you'll write LIM, that stands for limit x arrow negative infinity of the function. And then you'll have the same thing over here for positive infinity. I usually set them both up first, and most students like to do that too. Here's the only thing I'm going to caution you on, because this happens all the time, like at least 3 times on a test. This will happen to somebody, and I feel really bad. They'll set it up and then forget to answer it. And I can't give credit because it's blank. And a lot of times I try to grade things as you turn them in. Do you remember how I did last time? And I can catch it and give it back to you, but I can't catch them all. So please try to make sure you answer the question, because I feel so bad when I have to take off points because you left it blank, okay? Where do both of these arrows point? Up. So both of these are going to be positive infinity. Down would be negative infinity. All right, I want to try one more and then I'll give you a break. That one took a long time because we were going through all the things. And again, I'm not going to do every single part of every single one of these. I'm going to try and pick out what I think are the hardest parts and just do those. Let's just do number 5 because it's right there. What is this one called? Square root. So already have an idea in your head of what it should look like. It's going to be a half a parabola, but sideways. And it moved what direction? Up 4. Good. So go up 4, put a point. And then we're going to make a little table and try and plug in some more numbers. So let's, you know, this is going to be trial and error until we get something that works. Okay. What do you want to try and plug in? 8 times negative a half. Well, let's just do half of 8. What's half of 8? 4, except it would be negative 4 square root of negative 4. You can't do that. Okay. So let's do negative 8. So now the negatives will cancel. Half of 8 is 4. Square root of 4, 2 plus 4, 6. Good. So we get negative 8, 6, which I think is going to be right on the edge of the grid. So I can't go any further than negative 8 because it's going to go off the paper. But there is one more we can do that'll stay on the grid. Well, I can't plug in any positive numbers because then we'll get a square root of a negative, and that's not going to work. Let's try negative 2. Negatives will cancel, which is what we need to have happen. Half of 2. 1. Square root of 1. People forget about 1. Square root of 1 is 1. Plus 4 is 5. So negative 2, 5. So it'll look like this. We'll do the whole thing for this one too. And then after our break, I think I'm just going to pick and choose like some of the more difficult ones for us to do. All right, domain. Which direction do you read for domain? Left to right. Okay, watch me point to it. And you know what? Label negative infinity, positive infinity, if that's going to help you. Okay, left to right. Watch. We have negative infinity up until, where does it stop? 0. So it's going to be negative infinity, comma 0. And then you have to figure out brackets and parentheses. So what does negative infinity give? Yeah, that has to be parentheses. That can't be a bracket. How about 0? Bracket. It actually exists. It's there. What way do you sweep for range? But you have to start with which one? Open your eyes. Where you have to start. down to up, small numbers to big numbers. Watch me point to it. We're starting down here. There's nothing there, nothing there. Oh, what Y value do we start at? So 4, I know the hallway got noisy. You have to try and focus. 4, and then we want everything above that. Okay, so it's 4 to infinity. And you might be like, but Miss Cole, is that really going upwards? It's not in a great big hurry, but do you get that this is going to go off the paper and like onto the desk and down the room? Like it's going to keep going up forever. It's just not in a great big hurry. All right, what gets what? 4 gets a bracket because that point is there. Infinity gets a parenthesis. The rest of this should be pretty quick. How about your x-intercepts? Does this graph touch the x-axis? No, so none. How about your y-intercepts? 0, 4, you can kind of just see that one there. Increasing, decreasing. You have to read left to right. Watch me point to it. As I start over here, what is the graph doing? Going up or going down? Yeah. Decreasing. Is it ever increasing? No. So increasing, you can say none. And we decrease from where to where? Well, all the way on the left means negative infinity. So we decrease from negative infinity until 0. Now, for that one, I always say use parentheses for increasing and decreasing. If you put a bracket, I wouldn't care. On this one, it doesn't matter. Put whatever you feel. I'm going to put a parenthesis, but for that one, I wouldn't mark it wrong either way. Now, there's only one line for end behavior. This is like look left, look right, which is the only direction we can go. Yeah, left, there's nothing over here. So left is the only direction you can go. So LIM, that stands for limit, x arrow, negative infinity of the function. And again, my pep talk for that is it's shorter than what you were doing last year. So it's less work. So get on board with that. And where is that arrow pointing? Again, I know it's not in a great big hurry, but it's still going up. So you're going to put infinity. Kind of lazy, but it's still headed in that direction. So go ahead and flip over. We're going to look at number 2. Oh, whoops, went to the wrong page. So we're going to look at number 2. And what is that one called? As absolute value. All right, so absolute value. Can't write. And then you need to know the transformations in order to be able to get a graph. So what direction did it shift? Kind of backwards. Right 5? All right, so you're going to go right 5 and put a point. And then you can always make a table, but for absolute value, because both of the sides are linear, you can use that -3 as your slope. So from that point, just go down 3 over 1 in each direction. And that's going to be the V shape. Why is it upside down? It has a negative, it's the reflection. So you can just use that -3 as the slope and you can get your graph real quick. You can always make a table. That's an easy way to do absolute value. So I'm just trying to save you some work. Okay. Now again, we won't do all of them. I do want to look at y-intercept on this one though, because the common mistake is people will put none. And I get why that happens. Does it look like it touches the y-axis? No, but do you get that this is going to keep going and eventually down here it will run into it? Okay, so there is going to be one, 0 something, and you're going to plug in 0 and just see what you get. Now, it should be negative something or other, right? Okay, like, because it's going to be all the way down here. Here we go, 0 minus 5. -5, absolute value of -5. 5 times -3 is -15. And does that make sense like a logical answer? Yes. Okay, thank you for heads nodding. All right, and then, bless you, we're going to do maximum, minimum. This point is a relative what? Maximum or minimum? Maximum. Minimum would be none. It's going to keep going down forever. You can't put -infinity as a minimum. That's not a number. Now you have to write it backwards. This is the 0.50. If you don't want to write that, you don't have to. I'm just labeling it for you. You have to do it the other way around. So how would we say that? Perfect. 0 at x equals 5. If you're like, why on earth does it have to be backwards? Here's the reason why. Do you ever wonder that? Like, why on earth is it backwards? Specifically to torture high school students. No, it's because when you're doing a word problem, like imagine someone kicked a football into the air and then it came back down. NFL started. You all with me? If someone was like, what was the maximum? You wouldn't say 3 seconds, comma, 40 feet. You would say 40 feet. And then as a follow-up, if they wanted to know, you would say at time 3 seconds. Like that's why when you do an actual word problem, it makes more sense to say it the other way around. Okay. Let's look at number 7. Again, I made myself a little list here and I'm just picking out what I think is the toughest stuff. Like we're going to do the hardest part together. So what's this one called? Cube root. Perfect. What directions did it shift? There's actually 2 shifts. Down 4, good. Left 2, good. Down 4, left 2, that's your center. And it's going to wiggle sideways. So just be expecting it to look like this. Okay. Let's try and plug in a number. If you guess something that doesn't work, we'll just pick something else. You cannot mess it up. 6. Let's see if that works. 6 plus 2. 8. Good. Cube root of 8. Good. 2 times 2 is 4. Minus 4, 0. So 6, 0. Now you kind of skipped the one that I was thinking we would go for. Like you looked way out. Can you think of one that's a little closer to the center? Like that was awesome. But can you come up with one that's like a little this is the center. Can you get one that's closer to here? Like if this is at -2, can we do -1? Like you want to start out close to the center. -1 plus 2. 1. Cube root of 1, 1 times 2, 2 minus 4, -2. So -1, -2. And watch me point to this, because if you know the symmetry, it saves you work. If this is the center, do you see how you can take that point and just bring it down here? If you know what it's going to look like the basic shape, then you can save yourself a lot of work. Right? So it's going to do something like that. On this one, we're just going to do the intercepts. Again, I'm just trying to pick out the hardest stuff. X-intercept. Where's our graph touch the x-axis? Six, 0. You have to write it as an ordered pair. Now this is cool. I kind of like this, and a lot of people end up liking this. Some people don't, but I'll get you on board. Do you see how it touches the y-axis, but it's not at a super nice number? Okay, it's going to be 0 something, and all you're going to do is plug in 0 and then walk away. So watch this. This is so cool. I get geeked out over this because I love it. 0 plus 2 is 2. Cube root of 2. Without a calculator, I don't know what that is. It's some decimal, but here's how you write it. 2, for this 2 that's out front, cube root of 2 minus 4. I didn't leave enough space. Minus 4. 2 cube root of 2 minus 4 is a totally acceptable answer because you're not allowed a calculator. So if you're not allowed a calculator, you just do nothing. Isn't that great? Plug in 0 and then whatever it is, just write that. Cool? You'll get on board. I like that. It's no work. 2, do you want to know what 2 cube root of 2 minus 4 is? No one cares. 2 cube root of 2 minus 4. Negative 1.48. Does that make sense? About where that was? My picture wasn't real great. So, all right, let's look at number 8. We're going to do a few from that one. What is this called? Good. Rational. How did it shift? Up, down, left, right. Up 5, right 3. Okay. This is the one with the asymptotes. That's why I picked it. right? We're gonna go up 5, dot that in, and then right 3, dot that in. It's like your whole axes move, up 5 and right 3. Just the whole thing. And then you can just draw in your graph. It's gonna coast along here. So I picked this one because it has asymptotes so that we could answer that. What is your vertical asymptote? Where did it end up? Where's the vertical one? X equals 3. Good. Hey, Miss Cole, do I have to put the X equals? Yeah, because without that, it's not an equation. So you need that. Remember Hoy-Vux. So the horizontal one would be Y equals 5. It's not hard, but it's very easy to get backwards. So just be careful. And then we'll do domain and range and intercepts on this one because the fractions always bother people. All right, domain, watch me point to this. You're going to sweep left to right. You want everything to the left forever and everything to the right forever. But here's how I always say this. What number is not invited to the domain party? Who got left out? You sweep left and right, you get everything except who? Who got left out? 3 is not invited to the domain party. Here's how you write that. Negative infinity to 3, and then a U that stands for union. That's like a way of saying, hey, wait, I'm not done with my answer yet. And then 3 to infinity. What that means is you want everything to the left of 3 and everything to the right of 3, but not 3. Do you get that we're leaving 3 out? Did you do that at all last year with intervals? Or, oh, heads nodding. Okay, here I'm teaching it to you like you've never seen it in your life. You saw that? Cool. Okay. Who is not invited to the range party? As you go downwards to upwards, who got kicked out? 5. You're going to write it the exact same way, except leave out 5. 5 is not invited. You want everything below 5 and everything above 5, but not 5. Leaving it out. And then I just want to do the intercepts because fractions tend to scare people. So we'll do the intercepts. Let me do Y first because it's a little easier. You're going to plug in 0. We're going to plug in 0. So right here, if you plug in 0, 0 minus 3, negative 3. So this entire thing would be negative 1/3. Okay, so just off to the side where you've got some space. Negative 1/3 plus 5. That's what we got. We plugged in 0, we get negative 1/3 plus 5. I talked about this a little bit already. When you add fractions, you need a common denominator, which would be thirds. So negative 1/3 plus how many thirds? This is the $1 million question. How many thirds is 5? A whole 15. How'd you get that? Yeah. 5 times 3 is 15. And then when you put those together, how many thirds do you get? 14 thirds. So 14 thirds. That wasn't so bad, right? Common denominator. X-intercept is a little tougher. It's going to be something 0. You're going to set the whole thing equal to 0, and then you have to solve it. That's a little tougher, but I believe in you, okay? You're going to take this whole equation, just use the space you've got there, and set it equal to 0, and you're going to work that out. Fractions can be tough, but again, I believe in you. So what would you do to start solving? Subtract 5. Good, we're on our way. Oh, whoops. Then what? This is the hard step. You would multiply over the x minus 3. So I'm going to take the x minus 3 and multiply it to the other side. Watch how I do this. This is the easiest way to do that. Ready? Are you watching? You're going to scribble it out and just write it over there. I'm all about saving you time and being efficient. Okay, just scribble it out and write it on the other side. All right, cool. Now what? Distribute. So we're going to get 1 equals what? Yeah, now are you back to like familiar territory? Like we can handle this. Subtract 15, 1 minus 15, negative 14. Divide by negative 5. Why is it positive? Okay, cool. Perfect. Fractions can be hard. That's why I wanted to do that one. I just have two more we're going to look at. Let's go. All right, so we're going to look at number 9. You're going to be okay? You are going to be okay? Promise. All right, what is 9 called? I feel like I've been explaining this as though you've never seen it before, but have you seen a lot of this? Oh, okay. I always teach it like you haven't, though, because I don't want to leave anybody behind. Maybe I'll speed this one up. It's a swoop. It moved what direction? Down 4. Okay, so go down 4, dot that in. And we're going to plug in some numbers. What do you want to try? What's the easiest number you should go for? Good. 0. If you plug in 0, what is anything to the 0 power? 1, -4, -3. Good. I need another number. That would give you 2 to the -1. Don't want to do that. -1. Good. They would cancel. 2 to the first. 2 -4, -2. And then I want one more. Good. Negatives cancel. 2 squared. 4 -4, 0. Why is it swooping down? Because of the negative. And I'm just going to do range for this one. Or actually, I'm going to do the range and the end behaviors. The range gets people. You need to sweep downwards to upwards. Watch me point to it. Smaller numbers to bigger numbers. What Y value are we starting at? It's -4, and then it goes up forever. So your range is going to be -4 to infinity. Infinity has to have a parenthesis, but this is the part that gets people. Is this graph ever going to touch -4? No. So that also needs a parenthesis because it won't ever actually hit that number. It doesn't actually exist on the graph. And then we're just going to do the ends for that one. So limit LIM x arrow negative infinity of the function, limit x arrow positive infinity of the function. Again, the pep talk is it's shorter than the way you did it last year, so it's actually less work. So get on board. So where does this left arrow point? Up. So good, positive infinity. Where does this one point? To -4. It won't ever actually get there, but it's behavior. It's just where it's headed. It's leveling off at -4. So when you have an asymptote, it's going to be a number. And then all I want to do for the last one, for number 11, is the increasing, decreasing constant. We're just going to read it left to right. And you know what? I'll color code. I know it won't show up great on here, but when I take a picture, it will. So reading left to right. And here, if you want to put your negative infinity, positive infinity, you can go ahead and do that. If you don't want to, fine. Just watch me point to it. What is the graph doing first? Right, decreasing. So decreasing is going to be negative infinity until what number? -7. Beautiful. All right, so decreasing will be pink. All right, then what is the graph doing? Good. So increasing is going to be -7 until -5. Good. You have to look at the x-axis. And then what's going on next? This will be green. Constant is -5 to -2. Just sweeping left to right. All right, what did I use for decrease? Oh, I told you. What is the graph doing next? All right, so we decrease from -2. Okay, so what do I need to put since my answer's not done? U. -2 to +2. And then increasing 2 to 4. So union onto that one, 2 to 4. And then constant will be where to where? Infinity. Good.